So, yeah, today, I'm gonna write out some ideas that I've had percolating through my head for a while. Um, a lot of them are on the process of how software gets deployed to machines in a cluster. Normal people have way different things that they do on their free time, but I'm apparently a Linux VTuber, so this is my fate. So, specifically, what has been percolating through my head is from a conversation I had with a coworker about a config management system where the controller server is untrusted by the machines that it's controlling. This does sound kind of weird, but this also means that the controller server would basically be receiving instructions from like SREs or whatever, and then those instructions would be the things that are fundamentally trusted, and the control server would pass it on to the servers, and the individual servers would, either accept or reject it based on the signature of the instruction bundle. So, let's start by just writing all of this out. You know what? Let's schedule this post for tomorrow. I think it might be more ready by tomorrow. Some boilerplate. Happy Friday to you too. I remembered to actually put the date as the 22nd instead of in 2022 instead of 2021. This is a ongoing battle. I mess this up in my notes all the time. There are so many things in my notes that I've had to go back and correct and say, yes, this is actually 2022, not 2021. God, it would be hilarious if I made the folder in my notes for January 2022 labeled as 2021. I probably did, but I'm gonna go check that. I lost the... So... let's just list out, like, all of the important things here. So, let's list out the ideals. Ideal of the NixOS model. The NixOS model is where you ship config and code as a unit. Activation script to enable that, and supporting tooling, and then all the supporting tooling to glue everything together. Where's the trademark emoji? So the idea that I have is that I'm building off some ideas that it's funny because I've since persuaded myself that this is probably not worth it from a threat model point of view. Either way, I think it might be interesting to develop this, to write this idea out, even if only to channel the Hacker News effect, where people are going to tell you what you're going to get wrong, especially if you're not presenting as male on the internet. However, you can use this effect to your advantage. Me right now complaining to the OVRT tab.
Tiny flames will dance across the darkness.
But yeah, the idea here is that you have a bundle of files that, for historical reasons, because I was at Heroku for way too long, we're going to call a slug. The slug is going to have a bunch of files that will define the version of the application, and then it is also going to define the steps to take to move to that new version. This will probably be a shell script. Realistically, it's going to be a shell script. And then the SREs will, one SRE will propose a change, and then sign it, and then another person will review it and then sign it themselves. So the name of this, by the way, comes from two things. First, because of a story that Socrates totally made up to absolutely clown on someone. Let's pull that story up over here. You know what? Let me just read it out loud for the added philosophical benefit here. And let me take a quick swig of water first. The Egyptian god Thoth lived in the Egyptian city of Naucratis. Thoth was the inventor of many arts such as math and astronomy, but the most significant was the invention of writing. Thoth showed writing to the king of Egypt, claiming that it would make Egyptians wiser and give them better memories, that it would vastly improve both the memory and the wit of the Egyptian people. The king replied, "Thoth, you invented this tool. As such, you are not the best one to judge such things. You have not created a tool to aid memory, you have created a tool to aid forgetfulness. Learners will not use their memories, they will blindly trust these sigils and not remember for themselves. You have discovered an aid to vague recollection. As the users of this tool will not be given truth, they will only be given a semblance of the truth. They will be hearers of many things and learners of nothing. They will appear to know all the knowledge of the world, yet when they were asked, they will only be the middlemen to external forces that are trusted without verification. They will know wisdom, but not truth." Let that sink in for a moment. God, the blinking detection on this thing, oh my gosh. I'm gonna have to, like, edit the heckin' blinking detection, because it's just, like... It is detecting me blinking when I am not. I may have to retrain this model or something. Yeah, like my eyes are open right now. But open C-Face is just not detecting it very well. God, this is bothering me. I may end up switching to Windows for this. But in general, the idea here is that we don't want people to know how to deploy things manually. Because deploying things manually is how you get to chaos. This is sort of going to be like, I guess, an unframework for deploying things. Most of the time, you'll have a framework like Kubernetes that will do a certain set of things in order to converge to a specific system state. And this is more like the middle path for people that just want to be like ruthlessly productive and ensure that only trusted people are able to modify servers. Another thing to keep in mind is that we also want to have an emergency escape path for only one signatory being able to deploy things. Like, let's say it's 3 a.m. The server's down because of like a one-line change in a config file that only got affected at 3 a.m. for some reason. You'd want to be able to just hit the button and make the thing work again, you know? So, the escape hatch must be loud. There must be a lot of evidence that something has been done. It must be loud, and it must additionally be impossible to work around. So... other components here are going to be the components. Let's go over the components. So we're going to have one of the main components be a CLI tool on dev machine on human machines. And then you want the coordinator. And then we're going to call the thing that we pluck on each computer an agent. I'm also thinking that maybe the thing that should be doing the signing is SSH keys, if only because they're ubiquitous. And at the very least, Go has some convenient APIs to make signing things easy, and everybody basically already has an SSH key, so we don't run into the Pgp problem. The Pgp problem, by the way, is the problem where you have to have a separate special key to use for PGP. And if you don't use it very often, then it's likely to bit rot and you won't be able to use it when you need it. By using a key that you already have and is already trusted other places, you're able to have more reputation for that key. This is probably violating the principle of like using the same key, not using the same key multiple places. However, I don't know if that's actually a real concern in practice. Let me just make a quick little development environment here. With packages, go please, go imports. How do you back up SSH and PGP keys? I don't have a good method to manage them. So I'm gonna do that senior SRE thing, and I'm gonna say it depends. Like, backups like that are kind of a personal thing. Everybody really has their own special way of doing backups like that, and with sensitive things like this, I don't know. My big strategy for backing up SSH keys is that I don't. Like, I do not back up my SSH keys at all. They live and die on the machine that they were on. In some very rare cases for SSH keys that I've had for like literal years, I will move the private key to another machine, just in case I need to get into stuff that's only available with that old key. But in general, my backup process for that is I either back up my entire home directory or the SSH key lives and dies on that machine. PGP keys, most of the time I will put them on like hardware like a YubiKey, and they will be generated on the YubiKey itself, so I have no way of backing it up. I don't really use PGP that much anymore. Fair warning. I've kind of given up on PGP because of how, like, baroque, bespoke, and just absolutely annoying it is to deal with. Sorry, I don't really have any useful answers there. Other than, like, don't, lol. But I don't think that's really the most helpful advice. So, let's just, I want to get rid of PGP too, but I need it for signing get commits. You can sign get commits with an SSH key now. Does GitHub support this yet? Hi, thanks for this feedback because it helps us prioritize. The GitHub repo team is also excited to see SSH commit signing and supporting Git. We're anxious for GitHub's commit support validation to support it. This would have been something that would have been great to support at the same time that Bit began supporting it. We've recently expanded in the GitHub repos team, but are still hiring to be more capable of that in the future. It's on our near-term backlog, but we won't start working on it for 2 to 4 months as of December 12th. So, not yet. is the thing. But in the meantime, you can sign your Git commits with this, but since GitHub won't show it, it'll not let you get past review gates that require you to have signed commits, so I don't know how useful that is. So, as a starting point for playing around with this idea, let's try and use the Go SSH client to sign arbitrary files, and then verify those files. So, how do I open an SSH agent for something that's in memory? Or it's like the system SSH agent. Forward to remote, routes authentication requests to the agent given on the socket. Agent, but with this agent interface, how do you get a interaction with like an open SSH agent? So I have this SSH auth sock here. And let's drag this edge window out over here. And let's add it to the window capture X composite. Call it stream edge. We don't want to capture that window, but you know, thanks to the magic of OBS, that's the one that's going to default to. So now I want to decrease the window size until it's comfortably on screen. Awesome. And now we want to put VTuber model under it. So new client returns an agent. Wait. Wait, it's the extended agent type, which is what I want, I think. Yeah, okay, so new client returns an agent that talks to an SSH agent over the given connection. SSH agent 1 provides a Unix socket at the SSH auth sock variable, which is what I have in the code over to the right that you can't see. Okay, let's copy this code here. Hide the browser. And let's paste this code in here to start. Let's change this username to this, and Oh, right. Go doesn't automatically get things now because they broke that with modules, so let's run this. Okay, it doesn't fail. Cool. So we have the agent that's reading from there. Now, an extended agent is just a normal SSH agent, so we're going to import the language server here, and let's make some flags. So the type of this sign function has us sign it with an ssh.public key. So for key to sign with, we're going to say this is a flag string SSH pub key, and the value by default I'm going to copy that to my clipboard. I'm going to paste it here because we're going to be super secure. Even though this is just a public key, you probably have seen it if you look on my GitHub. And we're going to call this the SSH public key to sign with. Probably going to figure out a better way to get this in the future, but yeah. So we have the key to sign with and file to sign. Or fname, we'll call it. So now up here, we're going to go flag.parse. And this will use the Go's stuff to parse all the flags and put things in the right variables. So we're going to want to read the file, dereference fname, and if there's an error, we want to explode. So now we have the data as a byte slice. And then we can get a signature by using, or first we have to get a public key. In order to get a public key, we need to parse an authorized key. So underscore. So it's the type of the parse authorized key function is that we take in a byte slice, which in this case is going to be the SSH pub key flag. And then it returns a public key type, the SSH key comment, open SSH options, the stuff that it couldn't parse, and an error. So we're going to have the public key, 3 underscores, and an error. SSH.parse authorized key, byte, key to sign with. And if the error is not equal to nil, we want to blow up. So now we want to take the signature and the error, and then we want to take the agent client.sign hub key data, and if this fails, we want to explode. And now we will get a SSH signature back. So, we're going to import the JSON package here. And os.standardout. It's just so we can look at it. And to make it easier, I'm going to set the indent to nothing. I'm going to set the prefix to nothing, but the indent to space. This will format the thing. In Go, does log.fatal terminate the program? Yes. It logs the thing and then does the equivalent of the C function abort, where it will exit with status code 1. This may not give us all of the information that we need to debug the problem, but it should at least give us a good pointer. So we want to encode the signature to standard out. And then we want to sync the standard out buffer, or the standard out file, which is equivalent to flushing it. I don't know why they call it syncing. And then we're gonna want to validate it, right? Okay, so with the SSH agent, what's going on is that the SSH agent is the thing that's holding the private key. We're identifying the key to sign with the public key, but it's going to tell the SSH agent to sign it with that private key, right? And then with this SSH signature, what do we do to validate it? I have something in here. Ah, we verify it with the public key. Okay. So this right here is of type ssh.public key. So then what we can do is sig or pubkey.verify data and a signature. And that's just going to be the error there. And as for what to put in foo.text, I'm going to find some data. I have a good idea of data to put in there as a test. Okay, cannot... Oh, right. We need to dereference that because it's a pointer. Okay, so... when we create a signature, it looks like we get something like this. We get the format, which is the format, which I'm presuming is the format of the key, because that's what my SSH key is. And this binary blob of data. You can tell it's a binary blob because when the Go JSON parser or JSON generator encounters a byte slice, it will base 64 encode it. So this is probably some opaque string. Cool. Can we actually get the fingerprint of a public key? Yes, there is a fingerprint function. Let's see what it does. Let's not do printf, let's do print line here. Let's not make static check whine at me. Okay, yeah, I'm using an ed 215 to 519 public key here, so the fingerprint's probably not going to be much longer than the, it's going to be a bit shorter than the actual public key, so might as well use the public key here. Oh well, good idea. So here's the heart of it, basically. We have a bunch of data. We have a signature. We dump the signature to standard out, and we verify it. So let's spice things up. Let's add a second signature to the mix. So let's add another public key. This time, let's add a public key from one of my home lab machines named Cosmos. And, okay, so now we have two public keys in the mix. And because we have two public keys in the mix, this means that we can sign this with multiple keys. So, you know what? Let's say we have a slice of public keys that we trust. I'm pretty sure you can declare slice variables like this. We're gonna find out soon, though, because hopefully the compiler will stop me if you can't. But knowing its Go, it might not. So let's also grab this public key. Cool, we have all our trusted pub keys. So now we can write a little sign function. We have our agent.agent. We have and then we get back a pointer to signature error, right? So now the real question is, how are you going to want to validate which public key signs something? We'll figure this out when we get to it, but, then we'll just move this over here, and we'll put this as A, which is short for agent, because that's how you work in Go. And then we can get our SIGs as a pointer or a list of pointers to SSH signatures. And then for every public key string in trusted pub keys. I want to add that I am not a security expert, so please don't take what I'm doing as like the best practice for security. I am mostly playing around here. We want to sign with the agent client and the PK string and data. I'm going to move the data up here. If error is not equal to nil, then we're going to want to blow up. So then if everything goes successfully, we want to append everything to the signature list. And then verifying this is going to probably be also a okay, I kind of wish I had lazy static right now, but I think we can work around it. Okay, so we're going to take an SSH agent, a public key, and actually this makes the sign function kind of redundant. Okay, so let's just refactor this into this loop here. I don't know what I was thinking trying to make a function for this here. Turns out that it's completely irrelevant. Then we're going to want to put this public key into the list of public keys. This list of public keys is what we're going to use at the end to verify everything. So for underscore comma sig colon equals range sigs for right. That's not going to run, but let's just pretend that it is going for now. Sig dot no. Probably gonna need a wrapper type around the SSH key unless we want to abuse the fact that this rest field doesn't seem to be used. Sig.rest equals the byte slice of h.fingerprint SHA-256 of the public key. No, I don't want to get my current words. Wait, that's the keybind for it? What was it? I lost my train of thought thanks to accidentally identify like using a feature in my keyboard that I haven't used in a while. I have word per minute calculation built into the firmware, and I've totally forgotten which key it is. So for the sake of argument, in the actual agent, let's imagine that this pub key is loaded in some sort of configuration struct. But for now, we're just going to manually iterate over them. Yeah, so then if the the SHA-256 fingerprint is different from the little blob of data that we shoved in there, continue. Okay, let's see if this runs. Okay, so yeah, it's going to shove the SSH key fingerprint in there. I'm using the SSH key fingerprint as sort of like a, basically like a discriminator between the SSH keys. But at the heart of it, this is basically like going to be most the crypto here. I mean crypto as in cryptography, not crypto as in planet murdering. So then once this passes, they can go in and build the change set. Or go in and run the change set. So Since the other part of this is going to be that there's a slug, and the slug contains, like, all of the application code that's going to be run and whatnot, it's important to take a moment to think about what the slug format could look like. I'm thinking that we should keep it simple, and by keep it simple, I mean, like, talk about a tarball. So, and then activate.sh will activate the thing, whatever the thing is. Each change set is also going to probably have a... okay, so then let's talk about the change set. It's going to have a name. And this is going to be like name of the service, where service is used very loosely and could basically mean anything like, you know, like from the name of the program that's running to like the name of the function that is performing for the business. This is going to be a rostering. We're also going to have the version, which is user supplied. Maybe relates to a Git hash, but either way, it's going to be something. It's going to be like, you know, peg string. And the signatures. And every change set is going to have a slug associated with it. I'm thinking that the change set itself would be basically be like a JSON file or a glorified JSON file. Or something, I don't know. But let's say it's a JSON file for the sake of argument. So, let's make a package called internal, and let's define a change set. You know what? Package internal is an anti-pattern. Let's just call it change set. Going to be a change set, but we can fix the stuttering later. Okay, so name. So the service has a name. The service has a version. In GoDoc, am I supposed to, like, stutter the name of the variable when I'm doing this? I forget. We're gonna call that capital S SIGs, and then actually, we're gonna call this metadata, because the change set is actually going to be a combination of the metadata and the slug. So let's just call the metadata what it is. Metadata is the metadata for the change set. This will contain okay, so the real question here is that, like, the signatures are going to be the things that are updated from the slug, or in this thing. So we probably want to have, like, the metadata in there, and then maybe the signature should be a separate thing. So maybe there should be, like, 3 files. Or should there? I don't know. I'm gonna have to think about this, but I'm probably over-engineering this. Yeah, I'm definitely over-engineering this. So let's under-engineer it. Let's just put it in the main metadata file just for now as a test. So this is going to be serialized into JSON and put in, I don't know, an uncompressed zip file with the slug. Going to be a metadata JSON file. There's going to be a slug tarball. Okay. So we have the metadata as that. Then we have type. We have the actual change set, which is going to contain metadata. Metadata. Derived set of changes from what to call it? Let's not document this type for now because I can't think of it. And then we're gonna have something like, I don't know, FS, or... Yes, I'm over-engineering it, so let's, slug file string, and then... We want to validate it against a list of public keys. Error. So we want to have keys as a list of SSH.public key, and then we want to have we have a list of SSH public keys, and we want to have trusted keys. Min needed int. In this case, it's going to be 1, but it might be 2 later. And yeah, so then for underscore, comma. Oh, you know what? Let's have a slug hash. And let's make the thing that we're signing actually be the hash of the slug. We're gonna encode the hash as base 64 because I think that might be better. So, underscore, comma, k, colon equals range, trusted keys. Then we can crib from the code in main.go. I'm using a map here as a set, so then we can pubkey.verify, and if the error is not equal to nil, return error, and then we can set this fingerprint here. Then, to avoid signing it with the same key multiple times, we can do if underscore, comma, okay, colon, or got, colon equals that, got is true, then return we can fail if we sign the same thing multiple times with the same key in an attempt to work. Yeah. How is that? Oh. Expected semicolon found open curly brace. Oh, var got keys equals. Okay. Then we go to the change set.metadata.hash. If the length of got keys is not equal to min needed, then return we want it to be signed with that many keys, but it was only signed with this many keys. Right? Okay, that doesn't immediately crash the compiler with an error, so maybe that builds? Okay, it does build, cool. And, maybe we could derive the URL, or... So the other problem is how to get the things on the individual hosts, but, you know, it might be just as simple as, like, you know, the person proposing the change set uploads it to the control server validates that it's by a trusted key. Oh wait, the control server can't be trusted, so... Yeah, there's a lot that needs to be thought into this. Huh. Either way, let's see if we can fabricate a hash. Or a change set. Let's make a test change set. Let's not split. Let's put that there. Then e./change set underscore test.go. How do I generate SSH keys? Let's go back to the agent package real quick. And let's actually open the right edge window. That would be helpful. And then let's make this edge window visible to the stream. And let's go up here and find the agent type. Oh, no, this is just package SSH. Let's go down to agent. So when we add a private key, so let's fabricate things. So cool. So func I still have the Edge window open, but I'm gonna just be writing out a little test now. So we have, let's make a test for making a simple change set and then validating it. So CS : equals change set. Or no, let's make an agent first. Call it A : equals new keyring. We're going to make a new keyring. We're going to make an RSA key with the random reader, and let's go 2048 bits of entropy. Okay. And if we can't generate a key, we want to fail. So now a.add agent.added key, let's fill it. Now we're going to have no certificate here. You know what? Since everything else is going to implicitly be 0 anyway, let's just only set the private key, and if there's an error, let's fail. You know. So now let's pretend for a second that the little parable in the upper level of the repo is our slug. So md the slug location that, actually, let's just make the metadata with that. Or, you know what, let's just make the whole hack and change set. Change set, and then we'll just fill this, and then we'll fill this. Hash, we're gonna have this just be Hunter2 because it is the most secure thing ever. And for the signature, we're going to do, or rather, os.read file. We're going to read the slug location, right? And if the error is not equal to nil, then we want to explode as soon as possible. Gonna quickly get a SHA-256 hash. No, not SHA-156, SHA-256. Then we're going to write data, and then return h.sum nil. What does the sum function do? Oh, we'll figure that out later. SHA-256 sum of data, and and then we're gonna make sigs, and then a.list. We're gonna list all of the agent's keys. It should only be the one, but let's just do it the verbose way for now. Then this SSH agent type, when you do a list, it returns an agent.key, but it's not the heckin' actual SSH. Okay, we have an agent key, which means that Marshall returns key plob to satisfy the ssh.public key interface. Oh wait, an agent key is a public key, because the public key type is an interface. Oh, so with these agent keys, I can actually use it to sign things. Okay. So a.sign AK, and then we sign the checksum. Right? Then if the error is not equal to nil, we explode, and then we append that to there. And then we don't have to make up a hash because we have an actual hash now. We have the checksum, we have the signatures, we have slug lock. And then because we have the list of public keys that we got from the agent, and we need one. Because I forgot to add a heckin' thing there. Cannot use Pub keys is type. Oh, right, because Go hates you. So then we're going to need to whittle this down here. So because agent.key is something that implements the ssh.public key interface, we can assign things like this. Only signed with 0 keys. No. Oh, right, because sig.rest equals the byte slice of SSH dot fingerprint SHA-256 of AK. Right, because I made it silently reject things. Yeah, okay. So we have a change set, it has metadata, this metadata has signatures. You know what? Let's remove these JSON encoding attributes. They're not going to help us much because it's going to look ugly anyway. Okay. Let's make an initial commit, and I'm going to push it to my Git server. I self-host, and I think I'm going to call this stream for now. Copy this. Refresh, and I'm going to put the link to the Git repo that I just made into the chat. Thank you for watching if you've been sticking around to the end. I want to work on this more. I probably won't post an article about this tomorrow. I'm probably going to bake this a little before I get anything more specific. But either way, thank you for watching me experiment with things, and I hope that this was interesting. Peace.